Example 2 talks about an equation where it's relating the number of gallons of gas, which is the y, our vertical axis, that are left in a tank, and the number of miles traveled by a car. So that's our distance. So remember, our x-axis is our independent variable, and our y-axis is our dependent variable. So that means that the number of gallons that remain, that depends on how many miles the car has already traveled. So the question's asking, what are the intercepts and what do they represent based on this situation? So the first thing we need to do is find the actual intercepts. So the first one that's given to us is our x-intercept, which is 320. And if it's an intercept, that means our y value must be 0 if it's on the axis. So what does this mean? It means that when we have traveled a distance of 320 miles, then we have no gas remaining. So our tank of gas will last 320 miles, and then we will be out of gas. Our other intercept is on our y-axis, and any point on our y-axis is going to have an x value of 0. So we have 0 as our x and 16 as our y. So what does this mean in terms of our situation here? It means that when we've traveled no miles, then we have 16 gallons. So before we even start this trip, we have 16 gallons. So we just talked about a situation of x and y intercepts. Well, what if we're just given a function and we're asked to solve for the x and y intercepts? So we first have to identify what are the key features of our x and y intercepts. I just put some definitions on here. So relating back to the situation we were just talking about, whenever we have an x-intercept, our y value has to be 0. That is a given. Whenever we have a y-intercept, our x value has to be 0. So we have to use that information when we're solving for the x and y-intercept. So if we look at the question above, it's saying, what are the x and y-intercepts? So if I'm going to solve for the x-intercept, I'm going to set y is equal to 0, and then I'm going to actually solve for x. So I'll take my equation, y is equal to the absolute value of x minus 3. I'm going to set y is equal to 0. And then I'm going to solve for x. So I will add 3 to both sides. Remember, we do the opposite operation when we're isolating a variable. So I end up getting the absolute value of x is equal to 3. So you may recall that the absolute value means that x can be a positive or a negative, because after we take the absolute value of it, it will remain positive 3. So we have actually 2 different x-intercepts. Then we want to solve for the y-intercept. So the rule is, when we want to solve for the y-intercept, we're going to set x is equal to 0 and solve for y. So I'll take my equation here, y is equal to the absolute value of x minus 3. We're going to sub in a 0, and then we're going to isolate the y. So we take the absolute value of 0, which is 0, we subtract 3, and we get negative 3. So if we look at our coordinates, I just needed a little bit more room there. Our x-intercepts are plus and minus 3 and 0, and our y-intercepts are 0, negative 3.